Today we're going to look at finding the equation of a line. So to find the equation of a line in gradient-intercept form, all you need is the gradient. We find the gradient by finding the rise divided by the run, and the y-intercept, so this value for c when x is 0. So if I've got a graph here, very simple graph, all I've got is the x-intercept and the y-intercept, but from this I can determine the rise and the run. So you can see that the run along here from this point all the way to this point is going to be 2, and my rise is going to be -4. -4 because it drops down by -4. So the rise is -4, the run is 2, -4 divided by 2 is -2. Value for c is my y-intercept where it crosses the y-axis right here. So c is equal to -4. So therefore, in gradient-intercept form, y equals mx plus c, I can just substitute in my value for the gradient, m is -2, and my value for c is -4. Looking at an example here, it says find the equation of the line which has a gradient of 1/3 and passes through the point 9, 2. This is a bit different, so we need to think about how we can solve this problem. We've already been given the gradient, so all we really need is our value for c, the y-intercept. So if I've got y equals mx plus c, I know that m equals 1/3. Now I do know a value for x and a value for y that's on the line. So if I substitute this point in, this value for x here and this value for y here, then I will be able to get our value for c, because we'll have just one variable that we need to use algebra to solve for. So if I substitute in 9 for x and 2 for y here, so here's my x value, 9 here, my y value 2, then you can see that all I've got left is c. So 1/3 times 9 is 3, so I'm left with 2 equals 3 plus c. So the value for c that makes this statement true is -1. So c must equal -1, our y-intercept must be -1. So therefore we can write our equation in gradient-intercept form in y equals mx plus c. Y equals 1/3 x minus 1.